What's going on, everyone? I have a 3-question warm-up here for you, and I'm going to give you 10 minutes to complete it. But before you do, I want to give you a couple of hints on how to solve these. So if you look at letter A, there's 2 terms, and neither of them are perfect squares. So you should remember you want to solve this by going the greatest common factor. On letter B, there's 3 terms, so it's a trinomial. So that's where you're looking to do the whole X diamond to factor it. In letter C, there are 2 terms, and both terms are perfect squares. And then there's a difference of 2 squares, so that follows that special pattern from the other day. So go ahead and take 10 minutes to solve those problems. Pause the video now to come back and we'll talk about them. So now hopefully you've been able to take a look at those. And if we look at the first one, GCF, you want to look to see what do both terms have in common. Well, the number 16 and the number 24 both have an 8 in common. And then an x squared and an x both have an x in common. So that's our GCF right there. So now we figure out what goes inside the parentheses. And there's 2 ways to think about it. You could say 8x times what will give you the 16x squared. Or you can say 16x squared divided by 8x. Either way, both of those give you that first term, which is going to be a 2x. Then to find that second term, we do the exact same thing. 8x times what will give you a 24x, or 24x divided by 8x. And when we do that, we get a positive 3. So that is our answer factored completely. With letter B, doing the whole X diamond, remember this top one is always going to be A times C. So 2 times 5 is the number that goes on top. Then our bottom one is going to be our B. That's the positive 11. And you want to figure out 2 numbers that multiply together to be 10 that add up to be 11. If you need to write out all the terms or all the factors of 10, you can. 1 times 10, 2 times 5. There are no others. And which of those add up to be 11? It's 1 and 10. Since it has a 2x squared out in front, remember we write both of these over 2x. And when that happens, at least one of these reduce. This one on the left, 1 over 2 does not reduce. So when you tip that over on its side, you have a 2x and a positive 1. This second one, 10 over 2x does reduce to 5 over 1x. So when we tip that over on its side, we have an x plus 5. And then there is our answer factored completely. With letter C, a difference of 2 squares. So these are always going to be the hardest problems until they become your easiest. Since 4x squared is 2x times 2x, those will be our first terms. And the number 25 is 5 times 5, a perfect square. Those are the numbers that go there. And then we just make one of them a positive and one a negative. And there's our answers. Using some of that information combined with some of our old graphing stuff is what we're going to focus on today. If we look at this first problem, we're going to kind of work backwards. We're going to look at a graph and come up with some of the details, and then eventually we want to be able to graph based on the details. So if we first look for the vertex, we know that's always going to be the turning point. So right here is our vertex. And that vertex looks like it is at the point 1, -4. So we can fill that in for our vertex. The vertex is always that turning point. The x-intercepts are always going to be on this x-axis. So we look and see, where does our graph hit the x-axis? Right there and right there. So the x-intercepts would be here at -1, 0. And then right here at 3, 0. The y-intercept is always going to be when the graph hits the y-axis. So if we look at our graph here, it hits it in this spot, which is at 0, -3. That's our y-intercept. Sometimes, like an earlier unit, our y-intercept is the same as the vertex, but that's only when we had vertical shifts going up or down. Now we're going to get into ones that are also going left and right. Now let's look at what you did on the warm-up. It says factor the trinomial. So anytime we have a trinomial, we are looking to do the whole x diamond thing. A times C is what goes up top. So in this case, a -3. The B goes on the bottom, so a -2. And you are writing down the numbers that multiply to be -3 that add up to be -2. So the only numbers that multiply to be -3 would be a +1 times a -3, or a -1 times a +3. And which of those two add up to be -2? And that's this one. So we have a 1, -3. Like we did on the warm-up, because it's a 1x squared out in front, that's what's going to go underneath each of these two terms. Tip it over on its side, and we have a 1x plus 1 and a 1x minus 3. So that is factored. Now a new part, it says set each factor equal to 0 and solve. So we're bringing these down and we're setting them equal to 0. So x plus 1 equals 0. X minus 3 equals 0. So if we solve this like we've been doing all semester, we would say to undo addition is subtraction. So we would subtract 1 from both sides. We get an answer of x equals -1. Do the same thing for this one. To undo subtraction is addition. So we would add 3 to both sides, getting an answer of x equals 3. What I want you to notice for this next one, it says, how do these values compare with the x-intercepts? Well, earlier we got an x-intercept of -1, and we just got a solution to be -1. Then we got an x-intercept of 3, and we got an x-intercept, our solution to be x equals 3. So how do they compare? They're the same. And that's not a coincidence. In order to find the x-intercepts, you need to solve the equation by setting it equal to 0. So we can factor and then set equal to 0. Let's take a look at some more problems. Saying what is a possible equation in factored form? Well, we already did that. Up here, if we just rewrite it as a y equals that's going to be in factored form for that same equation that we already factored. Another name for this is intercept form. So always remember that intercept form is going to be the same as factored form. Let's take a look at another problem. Same thing, we're given a graph. We have to pull out some of the details from it. So if we find the vertex, it is the turning point, and we could see it right there. And if we count those values, we're at -1, +9. If we're finding the x-intercepts, we know it's where it hits the x-axis. So those two spots, and it looks like we have one at -4, 0, and then +2, 0. Our y-intercept is always where it hits the y-axis. So in this case, it's right there at 0, 8. Then we have to factor the trinomial and then set them equal to 0 to solve. Anytime there's going to be a negative out in front, we always want to factor a -1 out first. So if I factor a -1 out of each of these three terms, what I have left inside would be a positive x squared, then a positive 2x, because -1 times a positive 2x would be the -2x, and then we would have a -8, because a -1 times a -8 will give us the +8. Now that we factored a -1 out, we can do the normal x diamond with what's just left inside there. The -1's not gone, we just don't use it for our x diamond anymore. So up here we have an a times c, so it's just a 1 out in front here, in front of the x squared, and then the -8. The b goes on the bottom, so that's our +2. So we're thinking of two numbers that multiply to be -8 that add up to be +2. So that's going to be a -2 and a +4. Because it's a 1x squared out in front, we put both of these over a 1x. Tip it over on its side, and we have an x -2 and an x +4. But don't forget that this -1 is still there. The only effect that -1 had on the entire graph was it made it open down. We now set each of those factors equal to 0. Similar to the last problem, how do we undo subtraction? We add. How do we undo addition? We subtract. And we're getting solutions of x equals 2 and x equals -4, which is exactly what we were getting for our intercepts here and our intercepts here. So it is going to be the same every single time. If we go and put this into a possible equation, the form, we would just rewrite that whole thing down here at the bottom again. So we have y equals the negative, and then it was an x -2 and an x +4. That's a -1 out in front. So to kind of summarize what we were doing today, just pulling from graphs and then doing a little solving. In order to find the x-intercepts, you want to factor and then set each factor equal to 0 and solve. In order to find the vertex, we want to look and see what is between the two x-intercepts and then use that to find it. So if we come back up here, we'll go to the first one. I have my intercepts at -1 and +3. I know the vertex is going to be directly in the middle of those. So if I'm looking at what's in the middle, it ends up being kind of this invisible line because there's equal parts on both sides. If I count, I go 1, 2 to that side, 1, 2 to that side. It's directly in the middle. Well, that point is at -1. In order to find out how we get an answer of -4, we would have to plug that into the equation. So if I go all the way to my original equation here, and I put the -1 in for x, and I just simplify and do the math. -1 squared is a +1. -2 times -1 is a +2. And then we have a -3. So if we do 1 plus 2, oh, I see what I did. It's not a -1, it's a +1. So we have to plug a +1 in here. So we're getting a 1 and then -2. And then -3. So 1 minus 2 minus 3 would equal -4. And that's how we got 1, -4 as the vertex. So for our summary for that, in order to find the vertex, we want to find the value between the x-intercepts. Then we're going to go and substitute that number into the equation to find the y. And then in order to sketch it, we use the vertex and the x-intercepts and go ahead and make your parabolic function. Hope this was able to help you a little bit. We'll take a look at more tomorrow. Have a good day.